All right, folks. So last session we went over the fundamentals and did a brief intro to SD-WAN, and we had a lab session. It was cool. It was good. So now we're going to go ahead and dive a little bit deeper into SD-WAN performance SLA and link quality measurements. Okay. Um, After this section, you guys should be able to, of course, be able to configure SD-WAN performance SLA and identify how the Fortigate measures link quality. Okay. So this looks familiar, right? Whenever we did go into the lab and after we, added our members, right, our interfaces to the SD-WAN interface, we saw this screen, right? Because we had to take care of the second part. We had to go ahead and configure the performance SLA, right? Because again, at the end of the day, SD-WAN is software defined wide area networking, right? And the purpose of it, right, is to make sure that we are optimizing our WAN usage, right? Okay. We have business critical data going out of our, maybe our faster pipe and maybe non-business critical traffic going out of the slower pipe. Okay. So with the performance SLA, you're going to learn about, how to configure, right, the SLA targets, right, the link monitor and the link health monitor and the link status. Okay. So let's go ahead and take a look at it. So first things first, the link health monitor, right? So what is it, right? It's a mechanism that detects when a router along the path is stopped or degraded. Okay. What's the FortiGate going to do with the link health monitor, right? So what it can do is go ahead and check the status or the health, right, of each SD-WAN member interface participating in a performance SLA based on the detection mode you have selected, right? What are the detection modes, right? And I didn't cover this during the lab, so I do apologize, and I'm glad we're taking a look at it now, right? And so the active detection mode, right? What does that mean, right? Active detection mode means that the link health is measured by sending probe packets to the configured servers. We did this in a lab, right? And we saw in our packet capture, I don't know if you guys remember, that we saw constant pings from both interfaces, right? This was the link health monitor doing its job, okay? While in that active state, because we didn't change the detection mode, okay? Well, we also have the option of passive, right? And so the passive detection mode means that the link health monitor, right? It's going to go ahead and measure the link by using session information that is captured on firewall policies that have passive WAN health measurement enabled. I know that's a lot, right, to go ahead and add in and to track, but this is very important because if it's certain traffic, like your northbound traffic, right, inside out, you can go ahead and enable it. But maybe it's traffic that's going through, maybe you have an AP hanging off of the firewall, right? And it just has a guest SSID. You don't really care about that traffic, right? So you don't have to, you can configure that to be passive, right? Or something like that to go ahead and just track it, right? The last detection mode is prefer passive, right? What does that mean, right? It means that link health is measured by using traffic passing through the SD-WAN members. Okay, when there's no traffic passing through the member interface, probe packets are sent to the configured servers to measure the link health. So what does that do? So it basically starts out as being passive. Okay, if passive isn't working and we don't see no traffic being passed through those links, then it's going to go ahead and use the active detection mode and start sending probe packets to the configured servers to measure the link health. Okay. All right. Within the performance SLA link health monitor section, right, we can go ahead and configure 2 servers at most to act as our beacons, right? Right, our destination test to see if we have a good link or not. Okay. And what this does, of course, this guards against the server being at fault and not the link. That is the purpose of the server section, okay? It guards against the server being at fault and not the link, okay? right? So on the GUI, right? You guys saw a lot of things. You can see out a lot of things now, right? We can go ahead and specify the participants, right? That'll be a part of this performance SLA. We can say all SD-WAN members, right? Or we can go ahead and specify, maybe just port one or port two, what have you, right? You can also do the same in the CLI, and I didn't show you guys that. In the CLI, we can go ahead and go to this option. We can add member zero. We can go ahead and put that. And what that does is that's equivalent to adding all members as participants for the particular SLA. Okay. It's a little hat trick that I wanted to hand off to you guys, right? And this is where it gets tricky, and you guys definitely, again, encourage you guys to get your CCNA and learn a little bit about routing and switching, because this is where it gets funky. There are certain type of routes called a forwarding information based route entry, right? So a FIB route entry, right? And basically what a FIB is, right? First, a forward information based route is basically a route that combines where to send traffic um, via layer three, right? But using layer two information. Because by default, a router isn't a layer two device, it's a layer three device. But speaking about the OSI model and how packets are encapsulated, we need to know, right? We need to know where, from a layer two standpoint, where to send our traffic based on the layer three information, right? And we need to know where to send that at layer two because we need to go ahead and encapsulate it. If we don't know where to send it and to be able to encapsulate it and what to put as a destination, we won't be able to send it. Okay. So just remember that is a forwarding information base, and there's more information if you go ahead and study up on the CCNA, Net Plus, a lot of those things. Okay. I won't go into depth tonight. All right. But whenever you configure a link health monitor, a FIB route entry is added in the kernel. Okay. So behind the CLI, right? To reach the servers defined on the performance SLA page over each participant interface. Okay. You won't have to know this in depth for the exam. This is just good for knowledge. Okay. Um, and of course, the routes, right? If you get into the kernel, their flag has protocol 17, right? The kernel routes will act independently of using the usual sources of routing. Okay. All right. So last but not least, you guys see on the left the protocol options available for through the CLI, right, to test this performance SLA that we're setting, right? So the GUI gives three protocol options, right? We see ping, we see HTTP, and we see DNS, right? Just like on the GUI, um, but also we can go ahead and add TCP, Echo. I think you guys saw UDP Echo, TWAMP. Um, so plenty of protocols within the newer code. Okay. And of course, you can do these things on the CLI. So you would have a total of 3 options on the GUI and 6 options on the CLI. Okay. And this is all regarding SLA monitors. Okay. So we're still in performance SLA, but let's go ahead and slide our focus to SLA targets, right? So the QoS, right, the quality of service for the traffic associated with performance SLA is defined by SLA targets, right? So we can set our servers, we can set what protocol we're going to use, right? But what is going to be our a baseline, right? What are we defining as a good link or a bad link, right? There has to be something that is measured against, right? That's just science and math in general, right? So we have the 3 most basic things to use as tests, right? Latency, jitter, and packet loss, right? We can configure these thresholds um, to go ahead and test if a link meets these standards or if they don't, and if we need to go ahead and manipulate the way traffic travels via our links, right? And the software would do this, right? Because again, this is software defined wide area networking, okay? All right. So really need to go ahead um, it makes you understand just latency jittering and packet loss alone, understand what it is, right? Then understand what's good and what's bad based on your ISP, what you're being provided and what your baseline is, right? Or maybe on a 7-day rolling average, right? Maybe the latency average for your link is 10 milliseconds, right? For your latency, and jitter is 6 or 7, right? On a 7-day rolling average, right? Or 14-day rolling average. And the packet loss is, who knows, either 0 or 1, right? So you have to know your network before you're plugging these in. Please don't plug these in blind. Okay. All right. All right. Let's talk about link status. Right. We saw link status. It has a small section. All right. But it tells us what to do whenever we have failure. Okay. It tells us to, hey, right, here's what I want you to do if this happens, right? And you're telling the system to, hey, check the link status, right? Let me know, because again, this is software. Let the system know via software if it needs to transfer traffic to traverse another link. Okay. And so based on my measurements that I'm pulling, right, from SLA targets, if I do have a bad link, what have you, now right here is my then in my if then statement. So everything that I showed you previously, it's that if, now it's the then, right? And so if the then looks over here, right, and we see that, hey, check it every 200 milliseconds, right? And if that link is still bad every 200 milliseconds, right, and we check it 5 times, let's go ahead and just make this link inactive. Okay. And so we can configure all these, right? We can also say to update the static route, right? Because the thing that we want to prevent, right? We want to prevent the system to constantly trying to traverse traffic. And this is where we'll, your end users will see, hey, it was just working 5 seconds ago, now it's not working. It was just working 10 minutes ago, now it's not working, right? You're having flaps go on, right? Traffic is, going back and forth between different links, right? So you don't want that to happen. So you want to make sure that you set this very peculiarly for your environment, right? And make sure you test this out, you push it to its limit as much as you can in a lab, so it can effectively help you have that network security engineer. Okay?
I have a question.
Yes, sir.
So just to make sure I'm understanding correctly, if if it comes back up, it's just gonna still check it even if it goes down every 200 milliseconds, and if it comes back up, it'll start back flowing the traffic the way that it should be, that I have it configured, or do I have to do anything to make it go back?
That's up to you, being the engineer, what you would have to configure, right?
Okay.
Because the software is going to do anything that you tell it to do. There's no static settings, right? So whatever Donovan sets it as, hey, I want you to check. I want the interval of checking this link to be every 200 seconds, every 100 seconds. Okay. Failures before inactive, right? So if you wanted to check the link on this check interval, if you wanted to check it 2 or 3 times, let's say the check interval is 200. So and you wanted to check it 3 times, so it's going to check it for 600 seconds before it says it's a bad link, before it states it's a bad link, right? And so then if you have the option of update static route or not, it's going to go ahead and finally call it a bad link. Okay. And of course, again, the check interval is still going to keep checking the link to see if it comes back up and turns on. And the option of restore link after, right? It's still working based on the check interval, right? If the link comes back up, it's going to say, hey, keep checking, keep checking, keep checking, right? And even though it's up, if I check it 3 times and it's all good based on the check interval, right? Let's say we set it to 3 and it checked, after 600 seconds, it's pretty good. We're going to add that route back to the routing table. Okay? Does that make sense?
Yep, depends on how I configure it.
Yep. Okay. All right. So this is the fun stuff. And this is what I like to take a look at to see before I go ahead and deploy anything, right, is you want to go ahead and take a look and see what's that baseline I was talking about, right? How does, give me 1 second. How does that look, right? You always want to go ahead and get that baseline, right? And after you define your baseline, right, with the quality measurement section, right, you're able to see now, right? You're doing that week or 2 week baseline that I told you about. Now you can go ahead and see, okay, what's my jitter look like, right? What does that look like? What does my latency look like? What does my packet loss percentage look like? Okay, I'm getting that average. Oh, okay. So this is the average. I need to go ahead and manipulate my performance SLA. Okay, based on what I configured. Right? Maybe I'm pointing to bad service. Maybe let's not do 8.8.8.8. Maybe let's do the next hop. Right? Maybe let's do our ISP. Okay. All right. All of this is again making sure that the software is doing the work that an old network engineer, old network engineer would do, or network security engineer would do. Okay. You really have to make sure you know what you're doing. Okay. And once you do, guess what? The software is going to do things for you to alleviate some stuff off of your head and to assist you with troubleshooting, right? If you have a bad link. Okay. Because those things do happen and you have to reach out to the ISP and yada, yada, yada. Okay. All right. Let's go ahead and keep going. All right. So SLA, CLI configuration, right? Same thing we talk about, right? But we don't go to routing and then go to SD-WAN. The Fortigate actually have a section for SD-WAN. And to get there, you do config, system, SD-WAN, right? Of course, you would have to enable it first. I'm saying this from experience before you see any options, right? And then, of course, you can configure health check. You can configure, right, SLAs within the actual CLI. And as you can see, you can set the protocol, set the server, set the detect mode, and the thresholds for latency, jitter, and packet loss. Okay. All right. You can also set the HA election priority. So again, this guide, good stuff, but I recommend look at the white paper for performance SLA configuration on docs.fortinet.com, so you can go ahead and actually see what it does, what the CLI looks like, and what commands you can use in that mode. Okay. All right. In your lab, please test it out. Please try to do this, right? You can set the link for a certain speed and just test it out. Okay. This is just a little bit more what the CLI looks like as far as configuring performance SLA, right? You set the interval, right? Link status parameters, the fail time, what Don just asked about. You can set the SD-WAN members. Of course, again, set it to 0 to match all members. Everything you can do in the GUI is a little bit more advance more options within the CLI. Okay. All right. And with that being said, we are finished with the SD-WAN performance SLA section. Okay. So I have 2 questions, right? I'm going to go ahead and ask you. Okay. So first question, which link attribute is used in SD-WAN link quality measurements? Is it A, cost, or is it B, latency?
Would it be B, latency?
There we go. All right. Question 2. Which status check protocol is available only on the CLI? Is it A, TCP echo, or is it B, HTTP?
I think it would be TCP echo.
Okay, good stuff. All right, guys. So we are done with SD-WAN performance SLA. Any questions?
One for me.
Okay, Don? Oh, I think we lost Don. All good. All right, guys, I'll see you tomorrow, and we're going to go over SD-WAN rules, okay?
Alrighty, thank you.
No problem. Later.
All right, bye.